back to our channel. If you are new in this channel, we welcome you. So this is Dynamics Analytics channel, and what we do basically is that we make learning available to everyone that's willing to learn. So in this video, we're going to be learning data smoothing. We'll be using Pandas in Python. So the first video will be on moving average using the rolling method of Pandas. So the question is that actually what is this data smoothing? Data smoothing is a technique used to remove noise or outliers from time series data, making it easier to identify underlying trends and patterns. So what does this mean? Yeah, I have to confess to you that each time I'm performing a pattern or trend analysis, I always do data smoothing, because sometimes, like I said, trends or pattern is basically for us to know how the thing is going, or we want to know the sales per week, or we want to know the sales every three days, or we want to know the sales per month, something like that. So that is smoothing. So you have to neglect every other thing that is not within that range. So that we want to see. So in this Pandas actually provides several methods for data smoothing, but in this series of video, I'm going to be creating up to 3 or 4 videos actually on this data smoothing, because it's very, very important. So we'll be using rolling method, we'll be using exponential weighted mean, we'll be using the cumulative as well, using the expanding method. So, but first and foremost, we'll be moving on to rolling method. So to study the trends in New-Delhi temperature dataset, I got the data from Kaggle, and this is the link. So I'm going to put the link right in the description. So feel free to download the data, and then you could also try things out and see on how to perform that. So first and foremost, we have to import the libraries. So basically, we'll be using Pandas and also Matplotlib. Pandas for data manipulation and Matplotlib for the visualization part of the data. So then I've already downloaded the data, and I have it in the same directory with this Jupyter notebook. So I'm going to be importing the data right now using let's run this. So pd.read CSV. Then I'm going to be putting the name of daily name of the CSV file. Yeah, cool. So I'm going to indicate because it's a time series data, so I'm going to be indicating the index column, and it's going to be dates column. So let's see the first 5 row of this data set. Okay, cool. So this is what we have in the data. So we have dates, we have mean temperature, we have humidity, we have wind speed, and we have mean pressure. So feel free to use any of these variables. So in this course, I'm going to be using the mean temperature. So to do the to demonstrate to you on how to do data smoothing. So the next thing right now is that we will use rolling method to find the weekly and the monthly trend of temperature in New Delhi. Okay, and we'll be adding each of the results to this data frame as different columns. So first and foremost, we will do the rolling window. So using the rolling method. So what the rolling method is used to perform rolling window operations on time series data. So it helps in smoothing by taking the average or other aggregation functions over a specific window of data points. What does this mean? This means that we could also use mean, we could find aggregation, like standard deviation, variance, yeah. So we could use those ones to study, like if I want to see how a particular thing changes, like the variation, so I could just use the variation instead of the mean. Okay, so let's start that and see. Let's first and foremost see we have let's indicate the window size. The weekly will be 7 days, the monthly, let's say 30, right? 30 days. So now what we want to do now is that to this data frame, we want to add another column called weekly temperature. That will equals to df, the name of the original column that we want to perform smoothing on, then rolling. Then inside this, you have to specify the argument called window equals to, then the window size. So first and foremost, this will be weekly, right? So the aggregation function, let's say I want to find mean. Okay, let's say we want to know the average temperature over New Delhi weekly. So let's check the data again. Yeah, cool. So we have weekly temperature here. We have no, simply because the first 7 days will not be, of course, will be used to calculate the second week, subsequently like that. So what you could do is that we change this to tail. So you can see now, so these are the values for this. So the next thing that we will do right now is that let's try to visualize and see what we have for this weekly. Or to make things easier, let's just estimate the monthly one as well, and then we'll just visualize them together. So let's say we have this will be monthly temperature, then this will be monthly 30 days. Cool. So let's run and see. Yeah, cool. So we have the weekly temperature, monthly temperature. So another thing that we could do right now is just to visualize. Let's visualize and see. Okay. So let's visualize the three variables together. So that's is the first one, the original data, which is daily. Then the weekly data to input right here. The monthly data, put right here. So then just call this plots, right? So let me specify the vig size to be right. Then yep, plt.show. Let's see what we have. Need temp. Okay, cool. So this is the figure. So and it's showing both the mean temperature daily, the weekly temperature, and the monthly temperature. So you could see that at least they all follows a similar pattern. So let's say let me remove the daily. Sorry, yes, the daily. Let me remove the daily and see. We have only the weekly. Yes, cool. So this is only weekly and the monthly pattern. So we could actually see. So what this actually useful for is that when you want to remove some part of data that you are not interested in. So this is very, very important. And another thing you could do is, okay, let me change this to variance. Okay, let me change this to variance. Want to find variance. Let's run this. Okay, variance. Yeah, cool. This is another result entirely. You could say the variance. So how the data changes per week and per month. You could see there is a spike here. There's a spike here. There's another spike here. So what is happening? So this is when you begin to ask some questions and the likes. So it could also be standard deviation. Could be standard deviation. Let's change to standard deviation and see. Let's see what we have. Yeah, so this is another result too. So this is very powerful, and I use this very often each time I'm performing a pattern or trend analysis. So in the yes, so don't forget rolling method. It helps in smoothing by taking the average or other aggregation functions over a specific window of data point. Other methods. So in this video, basically, so we're going to be going to exponential weighted moving average. So I will be using EWM method of Pandas. So this method is used for exponential weighted moving averages. Now, how does it function? So it assigns exponentially decreasing weight to the observations. Now, what do I mean by this? EWM, like exponential weighted moving average, is very useful when recent observations are more relevant than other ones. In a case that you want to study, let me say, a transient phenomenon that just happened recently, so you could use exponential weighted moving average. Now, what do I mean by that? Now, there is a parameter that controls this, and it's actually called alpha parameter. I'm going to be practicalizing that to you. So we're using the New-Delhi temperature data that we'll be using. So alpha actually is a numerical value, and it ranges between 0 and 1. So it actually controls the calculation of exponential weighted moving average. So now this is the main point. A similar value of alpha, I mean the one closer to 0, creates a smoother, slowly changing line similar to a moving average with a large number of periods. Such as if you increase in the case of moving average, the larger the window, the smoother the line will be. So the same is applicable to alpha parameter that is pretty close to 0. So now, what about the high value? The high value for alpha tracks the data more closely by giving more weight to recent data. In other words, if you want to study recent observations, then you have to increase the alpha value. So basically, that is the explanation. So we'll be jumping right into data, and then we'll be doing we'll be using the EWM function. So first and foremost, let's set the alpha equals to, let's say we want to use 0.6. okay, since we want to study the recent observation. So from this, let's create a new column called EWMA, and that will be equals to the main data of mean temperature. Okay, so then we call the WM function, where we'll be indicating alpha to be equals to alpha. Then let's add this parameter as well, just to adjust. So we'll be doing the average. Okay, so let's check what we have in our data here. Let's see. Okay, nice. So this is the EWM column right here. So the next thing we want to do right now is that we want to visualize the data. So let's visualize this this new result that we have now. Let's say we have this now. Okay, so let's visualize with the original data, which is the daily, then this one that we just created, then call the plot function, the vig size equals to, let's use the normal 12/4, then plt.show. Let's see what we have. So nice. As you can see, that this data looks pretty close to the original data. Now, if we reduce the alpha value, let's say we have 0.2. Okay, let's reduce and see what we have. You can see the difference, the yellow. You can see the difference. So yeah, so basically this is how to use exponential weighted moving average. Just like the other ones too, you could also change this and use another aggregate function such as a standard deviation, right? Standard deviation, let's see what we have. So this is the standard deviation. So this is the standard deviation. So let me remove this so that we can study only the new data. Yeah, so cool. So this is the standard deviation by using exponential weighted moving standard deviation in this case. Okay, so it could also be variance. Could be variance as well. Could be variance. So this is what we have. So why this peak? Why this sudden peaks? So why this outlier? So these are the things that we could further study and know what is happening and what is going on with the temperature over New Delhi in India. In this video, basically, we're going to be doing cumulative moving average. So this is a bit different, and it's basically to see the pattern that a particular data is actually following. So, and that is, so what is a cumulative moving average? It's another technique for smoothing time series data. And how does it function? How does it work? It involves calculating the average of all data points up to a given point in time. So, and pandas will be using expanding method of Panda to perform cumulative calculations. So basically, we have the data with us already, which is let me view. So this data shows that we've already done the weekly temperature with using the weekly temperature and monthly temperature using the rolling method of pandas, and then this column here is for the exponential weighted moving average. So what we are going to be doing right now is that we're going to be adding a new column to it. So, and this column will be for CMA, that is the cumulative moving average. Okay. So how do we do that? Let's call it CMA, right? So, and this will be equals to so we'll be using the mean daily temperature. So then we will call the expanding function pandas. So let's put mean of that. Oops. So let's check the first 5 row. That okay. So this is CMA column is already added. So the next thing right now is that let's visualize and see what we have in our data. So this is CMA, and this is let's see, let me have mean temperature. So let's call the plot function, and vid size will be equals to 12,4. Then ELT.show. Let's see what we have. Oh, there will be an error because we did not add this to it. Let's correct that. Yeah, okay, cool. So this is what we have now. The CMA, which is the cumulative, is what you can see here. There is a kind of a sinusoidal pattern, and that we can actually see that too in the original data. As you can see, high, low temperature. So this actually shows a pattern that we have in our data. So, and if you like, you could also use, let's say, sum. Let's sum over. Let's sum and see if we're going to have a different result. So this is the sum, CMA. So it goes up. It goes up. So and we can see a kind of a sinusoidal pattern in our data. So basically that is how to. Let me see if we try other aggregating function. So yeah, you have a much smaller data. So basically that is how to use expanding method to do cumulative moving average, or cumulative whatsoever you want to use. So I'm going to be posting the last video where I'm going to be giving a more theoretical real world practical applications of data smoothing, and how each of these functions could actually be applied to various data sets if you're a data analyst or data scientist. So I'm going to be pointing your attention to some areas of your analysis where you could actually chip in any of this method for data smoothing. So, and this is basically what I have for you in this video. So if you've actually learned something, so kindly like the video, comment in the comment box if there is something else you want us to add to the video or something to improve. So let us know in the video, and also do well to subscribe to our channel so that each time we upload new videos, you'll be notified when you actually hit the notification bell. And thank you so much, and see you in the next video.